I'm going to go over some questions from the review. I'll try to go over as many as I can, but I don't want the video to be super long. So on these first few, I tell you right here, do second trace 5, okay? You're looking for where these lines intersect each other, okay? So I'm going to do number 3 because I think that's the one that's probably the most complicated one, right? Even though none of them are really that complicated. On number 3 is the only one that's not already both of the equations in y equals. Okay, I will tell you that on number 1, there's one solution at 2, -4. And on number 2, there's also one solution at -3, -2. Okay, if you put these into y equals, you will see that they just touch each other one time. And if you do second trace 5, enter, 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 it will tell you those solutions. On number 3, the first equation is in y equals, but the second one is not, okay? We need to get the y alone. And I think it would be easiest if I move the y over here by adding y. And if I move this 3 over here by adding 3. That gives me y equals -x² plus 3. And then I can just put it into my calculator. Clear out what's in there. x² minus 5 and -x² plus 3. If I graph them, I see that it's 2 parabolas. I also asked you to do a little sketch of these, okay? But I didn't do number 1 and number 2 because I'm trying to kind of go fast, and I think that those are kind of some easy ones. But these, you can see they cross here and here. We'll do second trace 5, enter, enter, enter. And the right-hand intersection is 2, -1. And I'm just going to say there's 2 solutions. And to get my left-hand intersection, I need to do second trace 5 and then move my cursor over to the left-hand side before I push enter 3 times. Okay, -2, -1. Okay, so those are my 2 solutions. On number 4 and 5, this is what we did last class, right, where they're asking about what the graph is going to look like. Okay, and I'm going to have the little chart that we did on our 3.7 notes that tells us that this is a dotted line. Right. Greater than is a dotted line in shade above. Right, I'm going to add that chart on the board so that you can remember that too. Right, this parabola, if you need to put it in the y equals to look and see what the parabola would look like, I would totally do that on the test. Okay, but as I'm trying to go faster, I'm just going to draw it. Okay, since it's a positive number, or there's not a number in front of the x², but it's not negative, it's positive, it's going to open upward, it's going to be dotted and shade above. So it'll look like something like this. And to decide if you're shading above or below, start at the vertex and just go up. It's kind of inside on this one. Graph will look something like that. And on number 5, this one is also going to be dotted, but it's less than. Okay, so it'll be dotted shade below. And since it's got a negative in front of the parabola, it's going to open downward like a frown. So it'll look something like that. Right, and if I start at the vertex and I go down, it'll look like that. Right, those should be pretty easy if you can keep up with what you're supposed to be doing. The next few problems are also from last class, from our 3.7. Okay, they want us to solve this inequality. They want to know, where is this inequality, x² plus 9x plus 20, where is it less than 0? Okay, less than 0, which is below the x-axis. Okay, that would be like
number 12 in the notes. Okay, and the first thing that we need to do is find the x-intercepts. Okay, and the easiest way to do that is to try to do it in your calculator. Okay, so I'm going to do x squared plus 9x plus 20. I have to set it equal to 0. All right, and I'm going to graph. And I can see, okay, it barely dips down below right there. All right, if I do second trace 5, enter, 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 I see I have an intersection at negative 4, 0. And I'm going to do second trace 5 one more time and then go over and see. I think I have another one at negative 5, 0. Okay, I have two at negative 5 and negative 4. Okay, and they want to know where is it below the x-axis. Okay, so it's only barely below there, between negative 4 and negative 5. Okay, so I'm gonna draw a sketch so it's a little easier to see. Let's see. Negative 1, negative 2, negative 3, negative 4, negative 5. It should look something like this is what my parabola should look like. It's not perfect, but it's a little easier to see if I draw myself a picture. Okay, less than, we learned in class, is going to be an and problem. Okay, because it's between two numbers. And they want, where is it below the x-axis? That'll be right here. Okay, so it's only below the x-axis between negative 4 and negative 5. Right, so we're going to use like this. Between negative 4, x is between negative 4 and negative 5. You do the smallest number first, x goes in the middle, and the greater number second. Okay, they go in the same order that they are on the number line. Right? And the reason that I knew to use less than is because they use less than here. If they have less than or equal to with the underline, that's what I would use in my problem. Okay. I can do the same thing with this one. We're at number 7, except for it's not, all the terms are not on the same side. Okay, so we can move something over to the left. Okay, I can plus 10 on both sides. Then I'll have x squared plus 7x plus 10 is less than 0. Since this one is also less than, it's another and. All right, and I can do what I did before, which is